So today we're going to talk about the image formation by lenses. Okay, so when you talk about light and optics, one of the main things that we need to think about is lens. Okay, two main things actually. One is lens and the other one is mirror. Okay, lens allows light to pass through, whereas mirror, the main function of mirror is to reflect light. If you shine a light on the lens, the light will pass through the lens. Actually, it will refract lah. But if you shine a light on a mirror, okay, the light will reflect. But our job today is not to talk about mirrors. Our job today is to talk about lenses. Okay, so lenses is our main idea today. And as I said earlier, our main job today is to draw. Okay, so a lens is made of transparent material, either glass or clear plastic, okay, with two faces, which at least one is curved. Okay, now there are only two lenses that we're very, very interested in, which is the convex lens, okay, as you can see over here. Okay, this is the convex lens over here. Oh, sorry. Laser pen, hold on. Okay, so this is the convex lens, and this is the concave lens. Everything else is just a plus, but we're not so interested in this for this class lah. Okay, we're more interested in the two main lenses, which is the convex lens and the concave lens. Okay, so first the question is, what are the effects of lenses on light and why are lenses useful? Okay, so this is an activity which I hope to do. Okay, if we have a array box over here, and I shine a light now, okay, on a convex lens, and then I do the same thing like this, but I change this convex lens to a concave lens. Okay, so what will happen is if I have a convex lens, so this is a convex lens over here, okay, what will happen to the light? The most important thing that we need to understand is the light now, after it passes through the lens, okay, and this is going to be a new word for some, okay, it will converge. Okay, dia akan menumpu. Okay, the word converge means to menumpu. So one main feature of the convex lens is that it is a converging lens. After the light passes through the lens, it must converge. Okay, and there are a couple of things that we need to take note of lah. And I think this is where you start copying. Okay, so a convex lens, when you do a ray diagram, okay, we're going to hear this word a lot. Okay, a ray diagram means a diagram that shows the flow of light when it travels in the air. So a ray diagram, when you draw a lens like this, you must first have this thing called the principal axis. Okay, the principal axis is usually 90 degrees to the convex lens. Okay, and usually we will have about maybe 3 or 4 rays lah. Okay, this one you can run draw, not so worrying. Okay, you can just sketch it out. Okay, but the idea is that you have parallel lights. Okay, similar to this kind of situation. Okay, the 5 lights over here are parallel, so you have these 5 parallel lights. Actually, if you draw 3 also, it's fine. Okay, you don't even have to actually draw this and this, not necessarily. But the idea is this: when we see a convex lens, we need to remember that it is a converging lens. So after it passes through the lens, it will meet. Okay, so just find a spot on your paper and then just make sure that the light, just draw a straight line across like that. Okay. And so what happens is the place where all the light rays meet. Okay, let me repeat that. The place where all the light rays meet is what you should label the letter F. Sorry, the F there is not very clear, but yeah, it's the letter F. Okay, so the place where all the light rays meet, you write the letter F. And again, this part of the lecture, okay, doesn't have to be drawn with a ruler lah. You can just simply draw as long as you understand what happens when the light rays pass through. When I tell you to use the ruler later, then that's where you take it out. And we call this point the focal point. Okay, so this is this is kind of like a introduction to all the important things about it. So there's the principal axis, and then there's the focal point. Okay, so the focal point is the point where all the light rays meet. Okay, all the light rays converge. That's called the focal point. Okay, now if you draw a dotted line from the focal point downwards and you measure the distance, okay, from the focal point to the center of the lens, okay, we call this the small letter f, and we call this the focal length. So there are two important things here. One is the focal point, a point. One is a focal length, which is a length. Okay, the length between the focal point and the center of the lens is what we call the focal point. So what happens to the light rays after it passes through the convex lens? It converges to the focal point. Okay, I'm going to call this line over here the center of the lens. Okay, so that you know. Okay, the center of the lens. Okay, so much to say that the definition of the focal length is the distance. Okay, definition of the focal length is the distance between the center of lens and the focal point. Okay, this is by definition. This distance from the center of lens to the focal point is what we call the focal length. Okay. In contrast, this is a concave lens. Okay, if you look at the convex lens just now, all the light converges. But what's the opposite of converge? Yeah. Okay, don't worry, this is online class, so you can treat me like Dora and just let me answer the questions on my own. Okay, so we call the light a diverging light. Okay, the light diverges. Dia kalau dalam bahasa Melayu is called mencapal. Dia tersebar selepas melalui the concave lens. Okay, but even when it tersebar, even when it spreads out, there is a rule. There's a rule on how it spreads out. Okay, there's still this thing called the focal point and etc. So let's take a look at the drawing of the concave lens. So the same thing. The middle line is called 1, 2, 3. Principal axis. Okay, and then you can draw the 5 light rays 1, 2, 3, 4, 5. Okay, the parallel light is over there. But the thing that you need to remember is that for the concave lens, the light diverges out. Okay, so the question that we need to ask is, how does it diverge out? Okay, so I would suggest that you start by drawing the first light ray. Okay, I'll give you the whole picture. You draw all 5, but the point in which all the light diverges out, okay, you extend it by a dotted line. Okay, and use that same focal point to draw the other divergent lines. Okay, so the point is all the same. Okay, this F, although it's on the other side of the lens, okay, is still called a focal point. Okay, and the distance between F and the center of the lens, okay, just like the convex lens, is still called the focal length. Okay, they are all called the same thing. It's just that for the concave lens, the parallel light rays diverge from a point in front of the lens. Kalau concave is they converge to the focal point. Kalau concave, they diverge from the focal point. Okay, there's a difference there. You converge to and you diverge from. So this one concave lens, there's a rule that we have to follow, that even when we draw the divergence, we cannot simply draw the divergence. Okay, it has to come from a certain point. Okay, and that's basically the rules that govern the drawing of this one. Okay, and this is where all the copying is going to start. Number 1, the focal point, okay, is a point where all the parallel lights are converged after refraction. The focal length is the distance between the center of the lens, or we call this the optical center, with the focal point. The object distance, okay, this will make sense in a little while. The object distance is the optical center with an object, and the image distance is the distance between the optical center with the image. When you come back, not when we come back, when you come back, I hope to do this activity with you all. Okay, it's a very simple activity. Just put the lens facing somewhere very far and then see how the image falls on the screen. Okay, something like this. Okay, put the lens, usually convex lens, because convex lens is easier to work with. Then there's a screen over there, and then you face it to window, face and far away object. What you should get is something like this. Okay, for example, this one is facing the window, if you can see over here. Okay, and what you need to do is align and adjust the screen, the screen over here, or the lens, so that when you see the image over here, you will get a sharp image. Okay, and then you record that distance over there. Okay, So you have to adjust the scale until you find the sharp image lah. It means the image yang paling tajam atau image yang paling terang. Okay, and that is called the focal point, the focal length. Okay, the focal length is there. So we will do this activity when you come back, but I just want to show you how it is like. I really hope that we can have the time to do this activity. Otherwise, I may do it next term. Okay, right. Let's talk about drawing the ray diagram for convex lenses first. Okay, let's begin with convex lens. Because this is the next part of the drawing, which is a lot. Okay, page 190. So the activity 2, just leave it first. Let's go straight to activity 3. Okay, so there are a few rules that you need to remember. Number 1, there has to be a ray that is parallel with the principal axis. And then once it passes the axis, the center of the lens, it must converge. Okay, so it goes to F. Okay, so this is rule number 1. The first ray diagram is wherever the object is. Let's say I draw the object over here. Let's say this is the object lah. Okay, usually we will represent the object with an arrow up like this. Okay, this can be a man standing, can be me, can be the microphone or whatever lah. Okay, but this is an object, and from the object we draw a parallel ray light. After it passes through the lens, it will converge. The second one is if let's say the object is here. Okay, let's say the object is here. The second light ray must be from the object through the focal point, and then after passing through this one, it goes parallel. Okay, so rule number 1 is parallel to F. Rule number 2 is to F first and then parallel. The third one is the object passes through the optical center. Ngam just pass like that. Okay, let's say the object is here. Okay, let's say the object here like this. Just draw one light ray pass through the center. There's no change of direction in this case lah. Okay, so when you follow these 3 rules, okay, when you follow these 3 rules, after is a straight line now, there's no after. Okay, when you follow these 3 rules, then you will be able to find where the image is. Okay, so the purpose of drawing the ray diagram, okay, is to find out where is the image. Okay, how far is the image from the lens? Okay, that's the purpose of drawing the ray diagram. Not just that, you also need to know what kind of image is it. Okay, so we'll come to that in a while. So this is just to show you what happens. This one, as I said just now, is parallel and then F. Okay, which is rule number 1 over here. Parallel and then F. So this is how it looks like. This one is rule number 3. There's no changing of this one. Rule number 2 is pass through the F first and then parallel. Okay, pass through the F first and then parallel. So this is rule number 1. This is rule number 3. And this is rule number 2. Okay. So again, this is a summary lah. Okay, what are the 3 rules you need to follow to find the lens, the drawing? Manakala, kalau convex lens, okay, remember as we said just now, convex lens is not a converging lens. It is a diverging lens. Okay, diverging lens means dia akan tersebar. So tersebar, we have to give it a slightly different drawing. Okay, so the first rule is parallel and diverge, but diverge come from F. Okay, so dia terbalik dari convex tadi. Tadi convex is parallel and then straight to F. But ini parallel, diverge, berpusat di F. The second one is diverge first. In a way lah, diverge first and then parallel. Okay, but even when it's called diverging, it is focused on the F over here. Okay, this one don't worry so much. Okay, not so important. I mean important lah, it's good to know, but not so important. The first and the third rule actually is more important. Okay, the third rule, same as just now. Pass through the center with no change in direction. Straight line without bending. Okay, so almost the same as the convex lens just now. Straight to F. Second one is to F first and then straight. Okay, or parallel lah. And then the third one is directly through the center, no change of direction, no nothing. Okay, so how it looks like in real life is straight to diverge, but from F. Okay, this is the center. This is a very funny center. Sorry, this is passing through the center. Okay, both of it passing through the center without refraction, just straight through, just like that. Okay, and this is the summary. Okay, so also when we come back, okay, I hope to be able to do this. Okay, but this is an experiment lah. Okay, and this is actually how it looks like. You have the object over here, which is usually represented by a candle. This is not in your this one, but this is activity 4. Okay, this is activity 4, which is much later down the page lah. Okay, but I just want to show you first, because after this we're going to start drawing, and when the drawing starts, it's going to be a big headache lah. Not really headache, but you know, just we have to do this. Okay, so this is how it looks like. Okay, this is the object that we use, a candle. In our lab, usually we use a light bulb. Okay, then we shine we put a lens in front of it, and we try to capture the image at the back over here. Okay, so as you can see here, one interesting thing is that the image over here is actually terbalik. Okay, it's upside down. Okay, so he moves it nearer and further away from the screen. But notice that the image is terbalik. The image is terbalik. Whereas the candle is facing upwards like this, right? But the image that we form is terbalik lah. Okay, so here is the image. Okay, so the reason why we have to draw this is to find out what kind of terbalik is this. Okay, this is another one. Okay, just to show you also the same thing. Notice that this is much further than just now. This was much nearer. Look at the size of the image. And when we put it further, look at the size of the image. There's a slight difference over there. When we put it very far, okay, notice that the image becomes smaller and smaller. So this line over here in the middle is the lens, okay? But to make things easier for us, we just draw the lens in the middle lah. We just draw the optical center, because that's the important thing. We're not so interested in the lens, but we're more interested in the optical center. Okay, so our 2 rules. Number 1 is parallel, and then once you hit the optical center, to F. Okay, draw the arrows lah. First line is parallel to F. Second line is F to parallel. Please draw this parallel, don't one draw. And then the third one is the one that is over here lah. Don't understand. Okay, let me show you the actual this one. Okay, so this is unfortunately this slide for some reason or another does everything terbalik. So it does the center first. Okay, it does the center first and then parallel to F. Okay, and actually you only need 2 points. You only need 2 lines. You don't actually have to draw the third one. Okay, because the idea is this. Once you find the point of intersection, okay, that's where the image is. Okay, there are some instances where they don't intersect, but the important thing is this over here on the left, this is the object. Okay, the place where it intersects, this is the image. Now notice a few things about the image. Number 1, since the image is formed on the other side of the object, we call this image a real object. Okay? Yes, I know. The Gen Z these days have changed the word real until it has lost its meaning. But bringing you back to reality, okay, real is an image that is formed on the screen. Okay? Yeah, so real. So that's the real image. Secondly, notice that the object originally is facing upwards. The image is facing downwards. So we call this an inverted image. Okay, that's terbalik lah. Okay, we don't say upside down in physics. We call it inverted because upside down sounds very clumsy. Okay. Okay, correct. Thirdly, somebody over here mentioned itu image kan macam pendek. Memang pendek pun. Okay, look at the object over here is high, but the image is smaller. But we don't say smaller, we call it diminished. Okay. So, make a side note somewhere. Whenever you write characteristics of the image, always go for 3 characteristics. Okay, there are always 3 characteristics of any image that you draw. Okay, so in this case, where the U is further than 2F, okay, then the image is real, inverted, and diminished. Okay, What does this object beyond 2f means? Let's say the focal length of the lens is 10 cm. 2f will be 20 cm. Which means that this object, you place it somewhere, maybe it's like 25 cm over here. You put the object 25 cm away from the lens. That's what this means, object beyond 2f. Okay, so the position of the image is between f and 2f. Okay, and this is how we complete a ray diagram. One of the panel experts here asked, what's the opposite of real? Opposite of real image is fake image, is it? No. The opposite of real image is a virtual image, which we'll talk about in a little while. Okay, now let's go to the second drawing, which is we put u exactly at 2f. So for example, if f is 10 cm, 2f is 20 cm. We put it at 20. Just now the object was at 25, beyond 2f. Okay, so in this case, follow the same rule. Parallel, after parallel, it passes through f. And then the second one is, usually we follow rule 1 and 3 because it's easier. Okay, the third rule is through the center with no vision. Voila, the image is formed again. You don't have to do rule number 2. You can choose 2 light rays out of the 3. It doesn't have to be all 3. Okay, but there are some instances where you will have to use rule number 2 because you cannot draw rule number 1 or 3. Okay, but generally we use 1 and 3 because it's easier. Rule number 3 is so easy. Just draw straight through the center. No need to think about anything already. Okay. Again, the important point is, and this is precise, if you draw your drawing correctly and precisely, you should get the image ngam at 2f. And not just that, okay, again, since the image is formed on this side of the lens, this is a real image. Okay. And I think I should write down now. Okay, a real image by definition is an image that can be formed on a screen. Okay, an image that can be formed on a screen is what we call a real image. An image that cannot be formed on the screen, for example, like if if you cannot put it on the screen, it's called a virtual image, like virtual reality kind of thing. Okay. Secondly, notice that it's still terbalik. So terbalik in English is inverted. Okay. Now, if you take a look very closely at the image, you will notice that it is the same height as the original object. And so we don't call this diminished anymore. We call this same size. Okay. In short, this is RIS. Real, inverted, and same size. I know. I purposely waited for RIS because everybody loves. It is the word of the year 2023 according to Oxford Dictionary. How sad. I know. Yes, for real. RIS is the word of the year according to Oxford. Okay. So coming back to the first one, is read. Okay, real, inverted, diminished. Read, and then the second one is RIS. Okay, real, inverted, and same size. Okay, try to draw the third one on your own. Okay, position of image is at 2f. Try to draw the third one on your own. Okay, in the first drawing, the object was 25 cm, like beyond 2f. The second drawing is ngam at 20, 2f. The third drawing is the object is between 10 and 20. Okay, again, this 10 and 20 is just example. If f here is 5, then 2f is 10 . So between 10 and 20, look at what happens to the image. First rule is parallel, straight to f. Second rule is straight to the center. You will get a very, very, very big image. Probably beyond your grid. Okay, probably beyond the boxes that they give you. Don't worry. As long as they meet somewhere. Okay, so the image is somewhere over here. Okay, where, it is this one. Okay, and so we come back to the characteristics of the image. Same thing. It's formed on the other side of the lens where there is a screen. So we call this a real image. Okay. Secondly, it is still terbalik. So we call this inverted. But the third one is where it changes. Notice that it is much higher than the original object. So it is not diminished. Diminished is smaller. It is not same size. This is magnified, okay, which is bigger. And the short form for this is rim. Okay, case number 1 is RID. Case number 2 is RIS. And this case number 3 is rim. Okay, notice how the object moves. Case number 1, the object very far away, 2 times. Case number 2 is object ngam at 2F. Case number 3 is object is 2F and F. Okay, this fourth one is a little bit tricky, but let's do it together. Oh, sorry, the position of the image is beyond 2F. I guess you can write this if you want lah.
So like the further the image is from F, the bigger it is.
Right. Okay, generally, in generally, so Ain was saying just now, the further away the image is from F, actually the further away the image, it seems to be the image is getting bigger and bigger. Or in other words, the nearer you put the object to the lens, the picture becomes bigger and bigger and further magnified. Okay, now this fourth one, let's do together. Okay, same first drawing, parallel to F. Okay, case number 4. Now we are putting the object ngam at F. So let's say if F is 10 cm, if your focal length is 10 cm, we put the object ngam 10 cm away from the lens. We see what happens. Okay, the second line, as we have been drawing so far, is pass through the center. And this becomes a problem for us. Okay, no matter how long you draw your line, it's never going to meet. Right, it's always going to be parallel. And that's the interesting thing. Okay, even if you extend it behind, it's still parallel. Okay, this is a very important feature. And so this is slightly different. Okay, the characteristics of the image in this part, it is unfortunately cannot be determined. Okay, it somehow has disappeared into oblivion. Okay, it's sort of virtual, sort of real. But in any case, we call this image is at infinity. Okay, the image is so big that we can't even see it, or the image doesn't exist, or the image exists but we can't see it. Is there a difference? It exists but we can't see it, or it doesn't exist? Okay, never mind. I'm being too philosophical and I haven't had lunch. So, okay, last drawing for this one, convex lens. Okay, same, parallel to F. The second drawing is straight through the center. But, voila, wow, voila again. This one seems to go further and further apart. It cannot meet. Okay, so if it cannot meet, then you have to make it meet somehow. Okay, and how do you make it meet? You extend it backwards. Okay, when you extend it backwards, you will get a place to meet. And since the object and the image are at the same place, you have to draw the image with dotted lines. So extend it backwards over here. And then after that, the place where it meets is where you draw the image. Okay, so this is a little bit different now. Okay, this is, since it is on the same side as the object, we call this a virtual image. Okay, you cannot see it on the screen. Okay, it will somehow magically appear in front of you or somewhere else lah. Okay, and it is not terbalik. Notice, it's not terbalik. So this is upright. And the image is bigger than the object. So it is magnified. And so the short form of this would be VOOM. Okay, the position, the image is on the same side of the object. Okay, so let's summarize all this. This one. The only drawing actually that we haven't covered is this one, because I don't think we have the space for that. Right? Yeah. Okay, so don't worry about it. I'm just going to show you all this. Most important thing is this. Read, RIS, RIM, VOOM, VOOM. And this is how you will remember this one. Okay. you have to remember if this is the lens, okay, so this is F and this is 2F. Okay, so in order to help you, so okay, at this position, the image is RID, R-I-D. Okay, at this position, at at 2F, this is RIS. And this is RID. Okay, thirdly, at this position, after RIS is what? After RIS is RIM. Yeah, RIM. Okay, at the fourth position is the pelik one lah, purple color. Okay, the fourth position over here, actually the image is at infinity, but we can also safely say that it is a Voom image. Okay, I like to call it Voom infinity. Okay, and finally, I've run out already, black color. Okay, and finally, at this position, the image will be Voom. So this is kind of like a good, I guess you can call it a shortcut method lah. Okay, to remember the characteristics of the image at different object placements. Okay, if I place the object at the light green, then you know, oh, okay, over here, the image is RID, rail inverted diminished. If I place the object at the dark green, then you know, oh, okay, the image is rail inverted, same size. So the most important thing to know is what is the F and the 2F, because that helps you. Okay, if let's say I said, let's say my lens over here, the focal length is 5 cm. So 2F is 10 cm. So if my object is at 12 cm, then you know already, oh, okay, the object is 12 cm means the image is RID, rail inverted diminished. If my object, okay, let me test you. Well, let me ask you a question that I will answer myself. Let's say the object is at 8 cm. I put the object at 8 cm. Which position is it going to be in? Is it light green, dark green, blue, purple, or black? It's going to be light blue. Blue, sorry. Okay, so if you know that the object is here, then you immediately know what is the image going to be like. It's going to be rim, rail, inverted, magnified. Okay, so knowing the focal length helps us to know where we put the object, what kind of image we're going to get. Okay, and this is always fun to remember. Read, risk, rim, boom, boom. And you can pretend that you're playing the car. And like, wow. Okay, so just remember, the further it is, read, risk, rim, boom, boom. Yeah, okay, you can sing it to yourself at sleep. Just remember also, the first boom is an infinity boom. Okay, so read, risk, rim, infinity boom, boom. Okay, so it helps you to remember where the distance is. When you increase the U, okay, U is what? U is the object distance. Okay, just remind you, U is the object distance. Okay, and then V is the image distance. Okay, so in this case, this is U and this is V. Okay, over here, this is U and this is V. Okay, this is something that Ain was saying just now. The further away the object, the image becomes nearer to the lens. Look at the U and V. Compare the U and V. Okay, compare the U and V in diagram 1 and diagram 2. In diagram 1, the U is bigger than the diagram 2. For the V, in diagram 1, V is smaller than diagram 2, which tells us that the further you are away from the lens, the nearer your image is going to be. And on top of that, the image is also to become smaller. Okay? I think if you're going to copy anything, this first line is very important. When U increases, V decrease. Okay, the image distance decreases and the image becomes smaller. Okay, let's move on to convex lens. The good news about convex lens is there's only 2 drawings and both the drawings are actually the same. Okay, so the first one is U beyond 2F, correct? U bigger than 2F. Okay, the first one, same thing. Let's draw the central line first. Central line is the easiest to draw. Okay, draw the central line. through the optical center. No need to worry about this because it doesn't change direction. Okay, the second one is parallel, but because this is a concave lens, okay, remember this is a concave lens. A concave lens is a diverging lens. And when it diverges, correct, it must come from the point F that is in front of the lens. Okay, therefore, it will be ta-da! I know. Okay, and notice that there is an intersection over here. And again, wherever there's an intersection, that's where you draw the image. Okay, that's where you draw the image. So it will be virtual because it's on the right side, on the same side as the object. It is upright because it's still pointing upwards. And what do you think? Is it same size, magnified, or diminished? Diminished. Okay. And the good news for you is that kan convex lens bahkan there's 5 different positions and 5 different characteristics. Read this dream, boom, boom. Concave lens is always and forever VUD. Always. Wherever you put the object, you will always get a VUD, virtual, upright, diminished. Okay, and the image must be on the same side of the object, which is why it's a virtual image. Don't believe me? Try the second drawing. Okay, second drawing. Okay, now you put just now the first drawing, the image is so far away from the lens. Now the second drawing, the image is so near the lens. So the same thing, parallel and diverge out. And then the second one is straight through the center. And well, what do you know? Intersection. It is still virtual, upright, and diminished. Okay, it will always be virtual, upright, diminished. And it's a good news. So you have to remember 10 different things. Convex yang banyak. Concave itu satu saja. Wherever you put the object, you will always get virtual, upright, diminished. Okay, so again, let me reiterate and remind you again that for any position, it's not like the convex lens. Convex lens can different position, different image. Concave lens, any position, it's always virtual, upright. Sorry, what's the third one? VUD. Thank you. Virtual, upright, diminished. Always and forever. Okay, so just to remind you, there are 2 types of virtual images. For the convex lens, is virtual, upright, magnified. Read this rim, boom, boom. Okay, there's no VUD in convex. Okay, infinity, boom, and then boom. And then the last one, concave lens, is virtual, upright, diminished. Okay, the last thing you need to know is the linear magnification of the lens. Okay, linear magnification of lens, the formula is very simple, V over U, the image distance over the object distance. There's another way to calculate that, which is the image height over the object height. High over whole. Wow. HI is height of the image. HO is height of the object. HI is height of the image and HO is height of the object. He-ho or hi-ho. Fine. Okay. But very, very important, everybody. Okay, there is a meaning to all these numbers. If your magnification is less than 1, then means your diminished image. If your magnification is the same as 1, then your image is the same size. But if your magnification is more than 1, then this is a magnified. Habis nama pun magnification, kan, pembesaran. Kalau pembesarannya lebih daripada 1, it is magnified. Correct. It's just like the ratio. It's also like transformation in maths. I don't know whether you learn transformation. Okay, but this one. All right, last question. Which of the position of the convex lens forms a magnified image? Convex lens. Tambah the U equals to F. Okay, although technically U equals to F is magnified at infinity lah. Okay, remember read, raise, rim, boom, boom. Yes, I'm writing. Okay, so read, raise, rim, boom, boom. This is U is more than 2F. This is U equals to 2F. This is U, sorry, this is the between one. F is less than U is less than 2F. This is U equals to F, and then is U is less than F. Okay, so these are actually what we call position names, like U more than 2F, U less equals to 2F. Okay, but I would rather you memorize the read, regime, boom, boom, because visualize it. Okay, where the object is, what is the image that you form? Okay, the further you are, then it's real, then the nearer you get, it becomes virtual, becomes bigger. It's MMM. So, yeah, so just one additional thing over here. Okay, my advice to you, besides doing the tutorial questions until finish, which means including the paper 2, okay, including the paper 2 questions, I think there's one or two drawing questions in the paper 2. Okay, but actually I would suggest that if you can, practice the drawings. Okay, because I find that it becomes easier if you practice doing it's like maths lah, you draw it more than once, again and again. Okay, you will get it. Okay, so like the handout that I gave you, right, you can erase it off and then draw it again, and then erase it off and draw it again until you're confident if you're drawing. Okay, this subtopic is quite easy. Okay, especially in the drawing part, but you have to do it more than once. Okay, so you do it again and again and again, and hopefully that muscle memory will help you to remember how to draw the images.